What's up, everybody? So, this video is introducing you to the idea of graphing. This is part of the Module 2, Organizing Data. One of the ways in which we might go about transforming our raw data into something that is more easily digestible, more readable for our audience, is by transforming our data into graphs. Okay, so there are some considerations that we make in how it is that we are presenting certain types of information, and we choose a graph that is most appropriate for representing the kind of information that we're trying to demonstrate or illustrate. So, first, let's talk about graphing nominal or ordinal data. Remember, nominal level of measurement is that which includes names or categories. Ordinal data is that which includes ranking or ordering. And so we would represent that kind of data using a bar graph. So bar graphs are histograms with spaces in between the x-axis values. Now, I know I've transformed this, I've kind of inverted this particular bar graph such that the categories are on the y-axis. But notice that there is space in between each of these categories. That space is actually meaningful. If you've ever been, just hanging around wondering, which you've never done before, why it is that bar graphs look the way that they do, it's on purpose. There's a very intentional reason. For nominal data, the space between the bars emphasizes the scale consists of separate, distinct categories. So, for example, if we're collecting data on the topic of racial identity, our categories are mutually exclusive. Someone who selects two or more races is selecting a distinct category from being white, which is a distinct category from being Asian, from being Black, from being Native Hawaiian or other Pacific Islander, so on and so forth. So, in a nominal, when representing nominal categories, that space is meaningful. It means that these are completely separate categories. For ordinal data, the space emphasizes that we can't necessarily assume all categories are the same. Recall when we were, going over the material in what is behavioral statistics, I mentioned the idea of collecting data on pain on a scale from zero, or was it zero? It might have been one, from 1 to 10. And while I might select a one and someone else selects, 10, how do we really know what is the difference between those? What's the difference? I know it sounds like, oh, well, obviously between 1 and 10, there's all kinds of difference. If the scores were a little bit closer, if I'm selecting a one, someone else selects a two, how exactly do we measure that to be an exact distance? So, in ordinal data, when you are presenting it in a bar graph, you are highlighting to your audience that the difference between those categories is unknown, right? There's not really any exact measurement of the distance between one category or another. So that's for graphing nominal or ordinal data. For graphing interval ratio data, we use histograms where we are listing the numerical scores or class intervals along the x-axis. The graph that I have here is a histogram for the age data that I collected. A bar above each x-axis value signifies a couple things. Firstly, the height of the bar corresponds with the frequency for the category. So, for example, for the people from 16 to 20, we have 19 people in there. From around 20 to 24, 15 people, so on and so forth. However, you're wondering to yourself, maybe you're wondering to yourself, but you said, me, you said in the last video that all these categories have to be mutually exclusive. And you are right, they do have to be mutually exclusive. And the categories that are represented in this histogram are, in fact, mutually exclusive. But this is a histogram. There's a reason for it. Four continuous variables. So these are variables that you don't necessarily know. There's an infinite number of values that we can continue to break the category down by. The lines along the y-axis that width is representing the real limit of the category. It sounds very easy when I'm collecting data on age to say, okay, well, someone who is 19 is not 20. Therefore, I can make that distinction between who is 16 to 19 versus who is 20 to 23. However, if we actually were to spend some time breaking even those ages down, we could have someone who is 19 years old, 3 months, 5 days, 6 hours, so on and so forth, right? You can continue to break down their age into an infinite number of categories. So, where you draw the line between the person who is, oh man, what would they be? 19 years, 364 days, 23 hours, 59 minutes. You see what I'm saying? Like the idea of who that person is versus who is the person that is exactly 20 is very, very, it's real. It's a very real difference. And so that's why these histograms, they have the width that they are, right? That person who is, that 19, 364, blah, 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 is like right, their age is like right up against the person who just turned 20, and so on and so forth. For discrete variables, each bar extends exactly half the distance to the adjacent category on each side. These are categories which have those, much more distinct differences, but it's still a little bit hard to determine where those differences, where exactly those differences are. Okay, so this is a very short and sweet video, only about graphs. This concludes a series of videos on organizing data for Module 2. As you are working through the material, make sure you're referring back to these videos, the PowerPoints. You're using the discussion board to help you interact with your classmates and ask those questions, and that you're reaching out to me when you feel it is that you need some extra support. Okay, so that's all I got. Appreciate y'all. I'll catch you next time.